In this video, we're going to be looking at concavity, the concavity of a function. Okay, so let's look at the objective of the video. You're going to have to be able to define concavity, find the intervals where the function is concave up or down, define points of inflection, find the points of inflection of a function, or state how many points of inflection a function has. Okay, so now here's what you need to understand, that what is concavity, right? So concavity is really defined as the shape of the function. Okay, how the shape of the function. Now when you're saying, what do you mean by shape? Well, we know that a function can go up or it can go down, and what tells me that? It's f prime. Concavity is going to show me how it goes up and how it goes down. Okay, now please understand, there's 3 ways to go up and 3 ways to go down. And some are going to say, what? Yes, there's 3 ways. So let me show you the first 3 ways that a function can go up. So what we have is, we have this dot and this dot. Okay, so that dot is that dot and that dot, and is this dot and this dot. Okay, now if you notice, a lot of you in Algebra 1, you were taught that you went straight up. So this one is a linear. It goes up linearly. That's it. Straight up. Now, this here, this is a shape. Look at this shape. This is going up, but it's forming like part of an N. While over here, it's going up and it's forming part of a U. It's forming part of a U here, and over here is part of an N. So the shape is going to tell me a lot about how it goes up. So the first one, we're going to say that the first one is increasing, but it's concave down, so it's increasing at a decreasing rate. So this one tells me my f prime, and the second one tells me my f double prime. Or some of you are going to say that f prime is decreasing. In other words, this means that it's going to be a negative derivative of the derivative. So what's the derivative of the derivative? It's the double derivative. And decreasing means that it's negative. All right? This one here, in this graph, we're saying that it is increasing at a constant rate. And then finally, on the last one, this graph here is you're increasing, you're going up. As I go from left to right, it's going up. So it's increasing at an increasing rate. So that means that the first one is f prime and the second one is f double prime. So some other people are going to say that it's also called f prime is increasing. Now this here means that the derivative is positive. So we're looking at, this means that the derivative is positive, but we're looking at the derivative of the derivative, making it the double derivative. Okay. Now the same way that there's 3 ways of going up, there's 3 ways to go down. The first one says we're decreasing because we're starting here and we're ending here. So we're going down, but it's decreasing at a decreasing rate. So this is f prime and this is f double prime. The first one is my f prime. All right, or we're going to say that f prime is decreasing. So this means negative slope, negative derivative. So the negative derivative of the derivative is negative double derivative. The second scenario, we're saying that is going to decrease at a constant rate. And finally, the last one is going to be decreasing at an increasing rate. So that means that f prime is negative, but f double prime here is going to be positive. Okay? So what is the definition? A graph is concave up on an open interval if f prime is increasing, okay, on the interval, or visually if it is a U shape. That is, if the shape forms part of the letter U, or the double derivative is greater than 0. So let me show you. You see this? This here, we're going to say that it is concave up. What I like to do is I like to write this out for my students. Concave up. And for the other one, I like to tell my students, oh, remember this. Concave down. So concave down forms an N, while concave up forms a U. So in this scenario, it is part of a what? U shape. And in this scenario, it would form part of an N shape. So if I continue, it would form an N. And over here, if I continue, it would form a U. So let's go back up to this one here. This one here, we're going to say that it's concave. And you would say, I'm hoping that you're thinking that's concave down. Well, this one here is going to form part of a U. So this is concave up, and this one is concave down. Okay? So this one is concave down, and this is concave up. Okay. So let me go back to concave down. A graph is concave down if f prime is decreasing, or the shape is going to be N shape. That is, forms the part of the letter N, or f double prime is negative. So remember that. Okay? If f double prime, if the concavity is negative, it's concave down. If the concavity is positive, if f double prime is positive, it's going to be concave up. Okay, so right here, let's look at this picture. Where does it look like it's U shape and N shape? So right here, I'm going to be looking at it. It looks like it's going to be U shape. It's U shape, U shape, U shape, U shape, and there's going to be a dot somewhere there. Oops, where it's going to stop. So I'm just going to say I'm going to say right there. That's going to be a U shape. So now it's going to form part of an N. So it's N shape right there, and I'll stop right there, and then I'm back to what? A U shape. So I want to know, where is it concave up? So it's concave up from negative infinity all the way to this x coordinate, and I'm going to say x is equal to negative 2. Okay, and now where else is it concave up? And I'm going to say from 2 to infinity. Now where is it concave down? It is concave down from negative 2 to 2. Now some people are going to say, hey sir, do I use brackets or do I use parentheses? And I'm going to tell you that we're going to use parentheses because this dot here, it is neither concave up nor concave down. That dot right there is neither concave up nor concave down. And those guys are going to have a special name. These are going to be points of inflection. Okay? And points of inflection are neither concave up nor concave down. So if it's not positive or negative, what does it have to be? That means that f double prime of x is going to have to equal to 0 to get what? To get your poise. And I'm going to say poise a lot, all right? And poise are points of inflection. Okay? So here we go. All right? So what we're going to do is we're going to find where the function is concave up and concave down. So the first step is to find f prime. What is f prime? F prime is going to be 6x squared minus 24x minus 5. Then I'm going to find f double prime. That's my second step. F double prime is going to be 12x minus 24. Now I'm going to take my second derivative and set it equal to 0. All right, so that means that 12x is equal to 24, and I divide by 12, I divide by 12, so x is going to equal to 2. Now, this is telling me that my second derivative is equal to 0, and I'm going to say right now that that is a possible point. Okay, it's a possible point. And you're going to say, what do you mean possible, sir? My second derivative is equal to 0. Yes. Just because the second derivative is 0, it doesn't make it a point. And this is a very, very important question that you know, mathematicians make a mistake. So that's why they'll put it on the AP exam. A point has to change concavity. Okay, so that means that if I'm concave up and then I go to concave down, this dot right here is a point. Now if I'm concave up and then I continue concave up, this guy here, my second derivative is undefined, right? That guy is not going to be a point because it did not change concavity. Okay, so what do we have to do? Well, we're going to go back and we're going to put my possible point here on a number line. And what I'm going to do is I'm going to do exactly like the first derivative. I'm going to pick a number here, so I'm going to pick 0, and I'm going to pick a number here, and I'm going to pick the number 3. And what I'm going to do is I'm going to plug them into my second derivative. So I'm going to take them and I'm going to plug them in right here. So let's do f double prime of 0. F double prime of 0 is going to be 12 times 0 minus 24. Now in this scenario, I don't really care about the value. I only care about the sign. Well, 12 times 0 is 0. 0 minus 24 is going to be negative. That means that it is negative. That means, this is F double prime here. That means that it is concave down. So now what I'm going to do is I'm going to try to find, what is it? F double prime of 3. It didn't matter what value I picked, it's always going to be the same. 12 times 3 minus 24. So 3 times 12 is 36. 36 minus 24 is going to be positive. So it's positive, it is concave up. So now, guess what? My concavity used to be negative, now it's positive. Therefore, I have a POI at x equals 2. And it is concave up from 2 to infinity. It is concave down from negative infinity to 2. And what I did was I was able to find all the information using my second derivative. Okay? So let me give you the formal definition. The formal definition of a POI is going to be a point where the graph changes concavity at that point, and my second derivative is going to equal to 0 or it fails to exist. Okay, so I already talked about the POIs. Now you're able to look at it. Look at the formal definition. So if I was to give you this graph and I says, how many POIs does this have? Okay, so let's look at it. Ready? This guy right here is going to be concave up. So somewhere along that, now it's going to be concave down. Then it changes back to concave up. And then it goes back down to concave down. Then it goes concave up one more time. So how many times did it change color? So as I'm walking here, it's concave up and then green. So there, right there is that guy. There's a change. So that's a POI. And now it's green. Now it turns back to pink. So that guy is a POI. Now it's pink and now it's going to go to green. So there's going to be a POI there somewhere. And then it's green. Then it's going to change to pink. So there's going to be a POI there somewhere. So that means that this one has 4 points of inflection. Okay. Now, what if I gave you the function and I said, find me the POIs? Well, the POIs is going to be exactly what we did in the previous one. We're going to find f prime of x, which is 6x squared minus 24x minus 5. I do f double prime of x, which is 12x minus 24, which we had already done. Then I set it equal to 0, and I find out that 12 is equal to 24, divided by 12, divided by 12. So that means that x is equal to 2. And the biggest mistake students will make is they're going to look at this and says, oh, I have a POI at 2. But in order to be correct, you have to test it. Okay? So I'm going to plug in 0 into my function. I'm going to get negative. Okay? And then I'm going to take 3, plug it into my function, and I'm going to get positive. It's concave down, concave up. So now that I proved that it changes concavity, now I can say that that is a point. So one of the things that I like to test is I like to give this one to my students. Let's pretend that f double prime of x is equal to x times x minus 3, x plus 4, x minus 5. And I says, all right, guys, I'm giving you the second derivative. How many points does it have? And some of you are going to look at that and say, oh, this is going to have 4. 1, 2, 3, 4. And I'm going to tell you, because I know the shortcut, the answer is 4 points. Okay, 4 points. All right. So then let's try now. Here's where I like to throw my students off here. Let's pretend I gave you this one. I said x squared, and then I gave you x minus 3 squared. How many points does this one have? And students are going to say, oh, it has 2. Okay. So what I'm going to do is I'm going to make my number line on this one. I'm going to put in 0 and I'm going to put in 3. Okay. So let's pick values in between. So I'm going to plug in negative 1, I'm going to plug in a 1, and I'm going to plug in a 4 into my second derivative. So I'm going to get negative 1 squared is positive, negative 1 minus 3 is going to be negative, but when I square it, it's positive. Positive times positive is positive. It is concave up. Plug in a 1. What happens when I plug in a 1? I'm going to get 1 squared, which is positive. 1 1 minus 3, all right, is going to give me a negative, but when I square this positive, that's positive. And then when I plug in a 4, I'm going to get positive and positive, that's positive. So I'm going to get concave up, and in the middle one, it was also concave up. Did you notice something? There was no change. So how can that be? Well, I hope some of you are going to be able to tell me the shortcut. It says, oh my gosh, Mr. Quintana, I got it. F prime of x is going to equal to x minus 3, x plus 7 cubed, x minus 5 to the 4th, x plus 6 to the 5th, x minus 9 to the 8th. And I'm going to say, how many poise does this have? And I'm going to tell you that in this scenario, there was no change because you were squaring it. So when you square a negative, it converts to positive, right? And when you square a positive, it stays to positive. So there's not going to be a change. So what you're going to be looking at the power. This is odd, this is odd, this is even, this is odd, and this is even. So we're looking for the odds. How many odd powers do I have? 3. So I'm going to have 3 poise. But this one here, I'm not going to have a poi at 5. I'm not going to have a poi at 9. All right. So let me do one more, just to make sure. F double prime of x, is going to equal to x minus 5 to the 6th, x minus 3 to the 4th, x minus 4 to the 5th, x minus 2 to the 8th, and x plus 1 to the 10th. How many poise does this have? That's the question. And the answer is, I hope you're thinking and saying, oh my gosh, the answer is 1. And that is correct. I'm only going to have a poi at x equals 4. And that's it.